Quadratic formula. Now, what the quadratic formula is useful for, which I'm going to show you what the quadratic formula is in a minute, is to solve quadratic equations. Like if we have the equation x squared plus 2x minus 15 equals 0. This is a quadratic equation. So far we've learned two ways to solve the quadratic equation. The first and easiest way is you just factor it. It's called the zero factor theorem, and you get an x and a 5 and a 3, plus and a minus, and then you set each factor equal to 0, so you'd say x plus 5 equals 0 and x minus 3 equals 0, and you would get x equals negative 5 and x equals 3. This was just the factoring method. Now, if you get another equation, they're not all factorable, such as this one, like x squared plus 3x minus 3 equals 0. This is a quadratic equation. You know it's quadratic because it has the highest degree as a 2. If you graphed it, it would be a parabola. It has two solutions. Sometimes they're the same solution. You might get 3 and 3, but there's always two solutions. And this one is not factorable. You could make your binomials, and there's no way you can do it. So we would do it by completing the square, and you would get an answer like this. X equals negative 3 halves. I'm trying to speed this up a little bit for you. Plus or minus the square root of 21 over 2. Now you would have to use the complete the square method. Remember where you toss that over there and replace it. That's not a method of choice. Most people don't like that. So that hence comes the quadratic formula. Now let's write down a quadratic equation in standard form. It's ax squared plus bx plus c equals 0. This is just a generic quadratic equation. What I'm going to do is I'm going to use completing the square, and we're going to derive the quadratic formula. This will be a quiz question for you. There's going to be a quiz question on solving deriving quadratic formula, and there's also going to be a quiz question on you're going to have to memorize the quadratic formula. So let's just try this. We're going to solve this equation for x. That's what we're doing in these two situations. We're solving it for x. We're saying x equals this and x equals that. This one has variables instead of numbers, but it's still solvable. So follow along. This is really fun and really tricky. Let's just see if you can get it. This will be an extra credit question when you come in, and just study it and see if you can get it. All right, we're going to solve this quadratic equation. Remember, we can't have a variable and you can't have a number in front of the x squared term. So first step in completing the square is we're going to divide everything by a. I kind of wish we could have done this one in person. All right. Now, we need to make this one right there a perfect square, so we need to get rid of it. We're just following the steps on completing the square. We need a replacement guy. We put this guy that's not a perfect square on the other side, and we add on our replacement guy. Now, remember how to get the replacement guy? You divide this term by 2 and square it. So let me just do this over here. So it's b over, we're dividing it by 2, and we're squaring it. Dividing by 2 is the same as multiplying 1/2 by a half. So we're going to get b squared over 4a squared. Whatever you add to the one side of the equation to keep it balanced, you have to add to the other side. What we made here is a perfect square trinomial that can be factored into x plus b over 2a. Just remember, this term right here is always the same as this term right there. They're the same. And then on this side, we need to find a common denominator. So our common denominator here would be 4a squared. This guy is missing a 4a. So we're going to get negative 4ac plus, and there's just going to be b squared, because this one has everything it needs to be that guy. All right, now we're going to take the square root of both sides. So you get x plus b over 2a equals plus or minus the square root, and I'm just going to do it separately, which is totally fine. I'm going to put this in a different order, b squared minus 4ac, and the square root of 4a squared. I just did the square root top and bottom, which is perfectly legal. You could have just put it over top of the whole thing like that. Okay, now we just have to get x by itself, and we're about done. So we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac over the square root of 4 is 2, so it can come out. The square root of a squared is a, so it can come out. And our final answer to this problem, final when we're solving it for x, which is going to be the quadratic formula, is negative b plus or minus the square root of b squared minus 4ac all over 2a. This is what's called the quadratic formula. This has to be memorized, and I want it memorized when you come to class on next Friday. Right there. We derived it. We solved this quadratic equation by completing the square methods to come up with the equation. So let's look at an example. You're going to like these. They're not very hard. So the problem will say use the quadratic formula to find the roots of the equation 3x squared. When they say the roots, they just want you to solve it for x. Minus 2x plus 5 equals 0. Now to use the quadratic equation, you need to know what a is, what b is, and what c is. A is the term and the coefficient of the x squared term. So you might want to write that down. So you get a equals 3. B is the coefficient of the x term, so it'd be negative 2. And c is the constant. So once you write those down, beginning of before the x squared term, the coefficient of the x term, and the constant, once you write those down, then you just take those numbers and you put them in for a, b, and c in the quadratic formula. So here we go. So you get x equals negative b, so it's already a negative 2, so a negative 2 would be 2, plus or minus the square root of b squared, so that's negative 2 squared would be 4, minus 4 times a is 3, times c is 5, all over 2 times a. So it's really just a plug and chug kind of thing. It's a little complicated. You'll see why in a minute. So we get x equals 2 plus or minus the square root, and if we multiply and subtract all those things together, we're going to get negative 56. Make sure you do your multiplication first and then subtract it from 4. All over 6. Let's see if we can simplify this a little bit. First of all, we have a negative number under a radical, so that's going to be an I. We can separate this into 2 over 6 plus or minus the square root of negative 56 over 6. And this takes a lot of simplification, so 2 over 6 is 1/3. 56 is the same thing as 14 times 2, 14 times 3. Wait, what is 56 divided by? So this is going to be the square root of 14 over, it's going to be 2 times, sorry about that, I got distracted, 2 times the square root of 14, and it's going to be I over 6. I kind of jumped ahead of myself here. So we're going to get 1/3 plus or minus the square root of 14 over 3 I. So 56 is 4 times 13. So it'd be the square root of 4 times the square root of 13 is 2. Whoops, this should have been 14. 14. Over, so it would be 2 square root of 14I over 6. And so this is your final answer to the problem. The hardest part in the quadratic equations is once you hit down here and you have to simplify. So you guys can give those a try. I ran out of space on my little palette here, so I'm going to end right here. So that's it for lesson 71.